All right, you guys, so section 3.5, we're going to be dealing with the composition of functions, f of x plus g of x minus multiply, divide, and then the corresponding domains that go with them. So for some indifferences here, if I'm going to add two functions together, f of x and g of x, I could simply add them together separately and simplify the function that I get. The domain is the intersection of the two domains by themselves, so the part that works for both of them. And the same for subtracting. And so we'll look at a couple examples as we go here. So this first one, given f of x and g of x defined as those two functions. And again, follow along in your book, guys. These are the exact examples that are in the book. Determine the domain. Well, the domain of f of x, because it's a quadratic, is all real numbers. And the domain of a linear, g of x, is also all real numbers. So the intersection of that is all real numbers. Negative infinity to infinity. And then find h of 3 using the definition. Well, the definition then, h of 3 is going to equal f of 3 minus g of 3. Okay? And again, f of 3 means go to the f function, evaluate it at 3. So if I put a 3 into that function, 9 minus 15 is negative 6. And if I put a 3 into that function, 6 minus 9 is negative 3. Negative 6 minus a negative 3 or plus 3 is negative 3. So if you're following along in the book, that's the answer to that first one. Now, find a new function rule. Okay, well, the new function rule is going to be just combining these two. So f of x, which was x squared minus 5x, minus g of x, which is 2x minus 9. And then I'm going to simplify that a little bit. So x squared is the only quadratic term. Minus 5x minus 2x is minus 7x. And minus a negative 9 is plus 9. So that rule would work for f of x minus g of x. Okay? Use the result to find h of 3. Well, now I could say h of 3 is just plugging a 3 into that equation over there. So 3 squared is 9, 7 times 3 is 21. Okay, and 9 minus 21 is negative 12, plus 9 is negative 3, just like we got on the previous slide. So two ways of doing the same type of problem. Okay, so let's take a look at one where the domains aren't all real numbers. So determine the domain for g plus f. Well, if you recall from a couple sections ago, I got to make sure that underneath the radical is positive. So if I said x minus 2 was greater than or equal to 0, I would get x greater than or equal to 2 for that domain. And the domain for g of x, since it's a quadratic, is all real numbers. Okay. Well, where do those intersect? Well, they intersect, or the part that's true for both of them is this part that's greater than or equal to 2. So that's going to be the domain for g plus f. Find a new function for h. Okay, our new function is just simply going to add these two together. Okay, so h of x is going to be the square root of x minus 2 plus x squared. Okay, that's what I get when I add them together. I can't simplify them, they're not like terms. Evaluate h of 3. Okay, well, first of all, is 3 in this domain? Yes, so I can evaluate it. So then h of 3 is going to equal the square root of 3 minus 2 plus 3 squared. Well, that's the square root of 1, which is 1, plus 9, sorry, that's a 1, equals 10. Okay, so that one's going to work out okay. Now, what about evaluating h of negative 1? Negative 1 isn't in that domain. Okay, so I can't do it. Okay, so we'll just say that this is undefined. Call it a day. All right, so far so good. Products and quotients, same rules apply, you guys. If I'm multiplying or dividing, the domain is the intersection of the two, with the exception of the f divided by g. We have to make sure the denominator isn't 0. We can't divide by 0. Okay? So given those two functions, determine the domain. Okay, so this one, 1 plus x has to be greater than or equal to 0. X is greater than or equal to -1. This one, 3 minus x has to be greater than or equal to 0. Subtract a 3, divide by -1, and recall that the direction of the inequality is going to change. Well, if I need to be greater than or equal to -1 and less than or equal to 3 at the same time, then my domain is going to be everything in between -1 and 3. That's going to be the part that's the intersection for both. Okay? Find a new function rule. Okay, when I multiply these two together, which is what they're asking me to do, I have radicals for both, so I can go ahead and multiply and then leave under the radical what I get when I multiply the inside. So 1 times 3 is 3. I'm going to get minus x plus 3x, and then x times negative x, and negative x squared plus 2x plus 3. Okay? And then use the result from part B to evaluate h of 2. Well, h of 2 is fine. That's in that domain. So h of 2 is going to be the square root, -2 squared, which would be -4. 2 times 2 is 4. So this is just going to be the square root of 3, 1.73, if you work it out on the calculator. H of 4, hey, 4 is not in that domain, you guys, so h of 4 is undefined. Okay, I can't do that. Okay, a couple new functions. Determine the domain. Well, the domain for that one is all real numbers. That's linear. This is a cubic. The domain for that is all real numbers. Okay, so in general, it would be all real numbers, except remember when I'm dividing, f of x can't be 0, the denominator, and 3 would make that 0. So my domain for this one is all real numbers except 3. I have to eliminate that as a possibility because it would give me a 0 in the bottom. So find a new function rule for h. Okay, g of x, which is x cubed minus 3x squared plus 2x minus 6, all over x minus 3. Okay, so I've got a new rule for that. I can simplify this a bit though, so I'm going to do some work off to the side. Let's see if I can factor that top a little bit. So with 4 terms, if you recall, I have to factor by grouping. So let's look at the first 2 expressions. I can take an x squared out, and then I'm left with an x minus 3. And the next term I can take a 2 out, and I'm left with an x minus 3. So this factors to x minus 3 and x squared plus 2. Well, there's an x minus 3 in the denominator as well. So those will cancel, leaving me with just the x squared plus 2. So that would be the simplified version of what I would get if I wrote that out, a new rule for it. Use the result from part B to evaluate h of 0. Pretty straightforward here, because if I put a 0 in, 0 squared plus 2 is just 2. And as long as it's in the domain, which it is, the only number that wouldn't work is 3, we're okay. All right, these ones are pretty straightforward, you guys. You could evaluate these in your calculator, maybe -5 store x, and then just type in x squared minus 3, and the calculator is going to evaluate that. All we're asking you to do is put a -5 in for x. So -5 squared is 25 minus 3 is 22. Okay? G of 5t, well, that says replace the x with the 5t. So if I simplify that a little bit, I get 25t squared minus 3. Okay? And this one, I'm supposed to replace the x with a t minus 4. Okay? Well, t minus 4 quantity squared, squaring a binomial, you guys. So I'm going to get 2t squared minus 8t plus 16. And then the plus 16 minus 3 can be simplified to that. Okay? And we've done some of this before. This part should not be a review for you guys. All right, the composition of functions. So f of g of x, written two different ways, means the same thing. The tricky part here is the domain. The domain of the composition is all the x in the domain of g, okay? So whatever you can put in for g in such a way that g of x is in the domain of f. And we're gonna have to take a look at a couple examples of that to see what that looks like, okay? So given that those functions f of x and g of x, find f of g of x. Okay, so f of g of x basically says, let's take the f function and replace the x with the g function, okay? And of course, instead of g of x, I could write 3x plus 2. And 2 minus 4, this would be 3x minus 2. Okay? G of f of x, well, the g function is 3, and then the x would be f of x plus 2. Okay? Well, f of x is the square root of x minus 4. So now we have that scenario. Okay? For part C, on example 6, they want us to determine the domain for A and B. Okay, I added this in there. It's not a part C that's in the book. But let's talk about it. Okay, so for this one, the domain for g of x is all real numbers. Okay? The range is all real numbers, so it spits out anything I want, but it's got to satisfy this. So underneath the radical has to be greater than or equal to 0, so that would be from 4 to infinity, okay? And then the second one, f of x, well, the domain here is only 4 to infinity, and I can spit out some positive values. So when I put in a 4, I get a 0, okay? If you recall just the graph of this one for a second, so you know, the graph is going to look something like that, you guys. So I'm only going to generate range values 0 to infinity. Well, when you put in a 0, you get a 2. So that's the biggest number, or the smallest number I'm going to get. And then I can get increasingly larger numbers. So for part B here, this was part A. For part B, we're only going to get 2 to infinity. Okay? Okay. A couple more compositions. So for f of x and g of x, analyze the domain. Okay, so following number 7 in your book, f of g of x. Okay, so for g of x, the domain here is all real numbers except 0. Okay, so I know I have to eliminate 0 from my domain because I can't put it into g of x. Okay, so the range for that is going to be all real numbers except 0 as well. If you remember, it's got 2 branches. You could graph it in your calculator to take a peek. And so what other restrictions do I have? So when I start putting numbers back into here, well, x can't, g of x can't equal 1 either, because if g of x ends up equaling 1, then when I put g of x in here, I'll get 0. Okay? So g of x, which is 2 over x, can't equal x minus 1. Okay? Well, what kind of x would generate that? Well, x would have to be 2, so I have to eliminate 2 as well, because then 2 over 2 would give me a 1, which would then go into there and give me a 0. So I have to eliminate 0 for this one, and I have to eliminate 2, because when I put a 2 in, I get a 1, which makes the denominator here 0. So we're talking about all real numbers except for 0 and 2. Okay? So that would look like that. And then g of f of x, of course, here, you can't have a 1, because that would make the original denominator 0. And I can't make this one 0 either. So is there any way that this function's going to be 0? Because if this function's 0, that would equal 0 in the bottom. So I would have to say, you know what, 3x over x minus 1 can't equal 0. The only way that happens is if x equals 0. So I have to eliminate 0 as well. So 1 and 0 are both eliminated for this one. So this one's going to look like that. And then C, find the actual composition and comment. So f of g of x, okay? I'm going to replace the x's here with g of x's, like so. And so this is going to be 3 times 2 over x over 2 over x minus 1. The only way to do this is to get common denominators. So on the top, that's an x. Okay, this one's missing the x, so I'm going to have 3x times 2, which is going to be 6x. Okay. I take that back. Forget that. I'm not adding on the top. So the top's just going to be 6 over x. But on the bottom, I need that common denominator of x. Okay, this was missing the x, so I'm going to have a 2 minus x here. Those x's in the denominator cancel, leaving me with 6 over 2 minus x. And we knew from the original that we couldn't have a 0 here, but now it's clear that we can't have the 2 either. Okay, it wasn't as clear to begin with, but once you compose them, you can see that. Okay? All right. I'm going to go back and erase that and do the g of f of x. Okay, so now g of f of x is going to be 2 over f of x, which is 2 over, okay? Instead of dividing by a fraction, I'm going to multiply by the reciprocal. Okay? And it maybe wasn't super obvious that the 1 is obvious, but it wasn't super obvious why 0 wouldn't work. Now it's a little more obvious why 0 wouldn't work as well. Okay? Okay, so now given a function, could we identify an f and a g that would make that h of x work? Typically what I do for this one is I say, okay, I've got something quantity squared, okay? So if I let g of x be what's underneath that, okay? And then f of x is going to be that something squared minus 3. Then h of x, f of g of x, is going to be taking and replacing that x with this. So I'm going to get what I started with. That's, I think, the easiest way to handle that. And they walk you through that in the book as well. I don't want to spend a lot of time on that one. Okay? What about an example like this? So you've got a graph, and they want me to find f plus g of negative 2. Well, remember, that's f of negative 2 plus g of negative 2. Okay? So f of negative 2 is just 2. Okay? And g of negative 2, the g function here is at 3. So that's just going to be 5. F of g of 7. So this is a little bit different. So this is going to be f of, okay, 1, 2, 3, 4, 5, 6, 7. G of 7, the g function's the red one. That's 1, 2, 3, 4, 5. G of 7 is 5. So now I'm looking for what f of 5 is. 1, 2, 3, 4, 5. The f function goes up to 2. That's just going to be a 2. Okay? The rest of them are pretty straightforward, guys. I think you can get them from the picture. If you look in the book, they have all of the answers for this one. But this is just going to be g of 6 minus f of 6. So go over to 6, g minus f, whatever that number is. Same thing here. G of 8 divided by f of 8. F of 4 times g of 4. I think you guys can get those after seeing a couple. Okay? A couple more examples, then I'll be done. The fixed cost to publish relatively made simple by no way is $2,500, while the marginal cost is $4.50 per book. Marketing studies indicate the best-selling price for the book is $9.50 per copy. Find the cost, revenue, and profit functions. Okay. So cost, okay, it's $4.50 per book plus $2,500 fixed costs. Okay. The revenue function, we're selling them for $9.50 per copy, so that's 9.5x. Pretty straightforward. And profit. Profit is cost, or revenue minus cost, you guys. So how much you make bringing it into the store minus what you had to pay for it. So that's going to be the 9.5x, which is your revenue, minus that 4.5x plus 2,500. And you could simplify that a little bit, but that's going to be your profit. Now determine how many copies must be sold for the company to break even. That means my profit is 0. So I want my profit to be 0. If I simplify this, 9.5 minus 4.5 is 5, minus 2,500. Well, so I add 20, if you follow example 10 in the book here, you guys, I add 2,500 to both sides, I divide by 5, x is going to be 500. So if I sell 500 copies, I'm going to break even. If I sell more, I'm going to make money. If I sell less, I'm going to lose money. Okay? One more example, then we're going to call it a day. Okay, given that the radius as a function of time is 2 times the square root of t, and the area as a function of time is pi r squared, or area as a function of radius is pi r squared. This should be r, you guys. Okay? Express the area directly as a function of time by computing a of r of t. Okay? Okay? That's going to be the area function evaluated at pi r squared. I'm sorry. I lied. It's going to be the area function evaluated at 2 square roots of t. Okay? And so that means I'm going to replace that r, pi times 2 square roots of t squared. Okay? And if I square that, 2 squared is 4, square root of t squared is t, so I'm going to get 4 pi t. Okay, so that's part A. Find the area of the oil spill after 30 minutes. Okay, so if t is time and t is in minutes, you guys, all I have to do is put a 30 in here. So this is going to be 4 times pi times 30, 120 pi. You can grab your calculator to get an approximation for that, but that's all that it's asking you to do. Okay, we're going to skip number 12. And then we're going to go right on to the assignment 5 through 55, the odds. Okay, so give that a shot. And as usual, if you have questions, email me, and I'll try to get back to you as soon as I can. Thanks.